everybody, welcome back, and we're going to begin 5.4 today, which is solving radical equations. We're going to start off the unit by learning how to solve with just a single radical on the side of the equation. Okay, so first of all, just like anything else, if we're trying to solve for a particular term, we want to isolate that term. So you want to isolate this radical on one side of the equation. So we're going to go ahead and add 1 to each side of this equation to isolate that radical. So we have a square root of x plus 5 equals 4. And from here, what we want to do is we want to eliminate this radical. So this is a square root. So the opposite function of a square root, or the inverse function of a square root, is square, to square it. So we're going to square both sides of this function, or of the equation, okay? So then we have x plus 5 equals 16, okay? And now once we have x plus 5 equals 16, now we can solve for x. So we're just going to subtract 5 on both sides. We have x equals 11, and that's my solution. I can always check that nice solution over here by plugging 11 back in here. So the square root of 11 plus 5 minus 1 equals 3. That'd be the square root of 16 minus 1 equals 3. Square root of 16 is 4, and that gives me my 3 equals 3, and so that checks out. Okay. All right, so here we have a cube root of x plus 2. So same thing, we want to kind of isolate that root, okay? So we're going to subtract 2 from both sides here, leaving us a cube root of x and then equals 2. So now we want to, again, square, or not square both sides. The opposite of a cube root is going to be a cube, okay? So we want to cube both sides of that function, not square root this time. So this is going to be x equals 8 this time, okay? And again, we want to check this over here. So we're going to go cube root of 8 plus 2 equals 4. The cube root of 8 is 2 plus 2 equals 4. And of course, 2 plus 2 does equal 4. So that checks out. So 8 is indeed my solution. Okay, so now let's solve each radical equation again. Go ahead and pause this if you'd like and try to do it on your own and see how you do. So once again, we're going to isolate this radical function by itself on both sides, or not isolate on both sides, isolate it by itself on one side, equals 2. So we're going to take this and square it on both sides. That will give me x minus 2 equals 4. And then we will take and add our 2 to both sides. So x equals 6. Notice I'm only getting one solution on all of these, right? And so I'm going to check this anyway. So we have square root of 6 minus 2 plus 3 equals 5. Square root of 4 plus 3 equals 5. Square root of 4 is 2 plus 3 equals 5. So 5 equals 5. And there you go. You have your own answer key for your test and your assignments. Okay? Okay, so here now we have a suspension cables from the Golden Gate Bridge's towers are further above the roadway near the towers and closer to the roadway near the middle of the bridge. You can figure out your distance from the middle of the bridge, x, in feet. So my x represents the distance from the middle of the bridge, okay? And the height of the suspension cable, y, at your position by using the equation right here. So about how far is the cable from the roadway when you're 200 feet from the middle of the bridge, okay? So this represents my x, right? 200 feet from the middle of the bridge. So we're going to take this and we're going to plug in. And first of all, actually what they want us to do is solve for y first, okay? So I'm going to multiply both sides by this 0.010583. So that will become 0.010583. X equals the square root of x minus 220. Or, excuse me, y minus 220. Sorry about that. Okay. And now to continue to solve for y, we're going to square both sides. Okay, and let's get my little calculator over here. So we have 0.010583, and we're going to square that guy. And that gives us about, this means that this exponent's going to be -4, so you have to move this decimal over 1, 2, 3, 4. So it's going to be 0.00011. And if you look at this here, this is going to go to a 2. From that 9, we'll just round that up to a 2 right here, okay? And then x squared. So don't forget to square the x also. So we square the number, square the x. And that's going to equal y minus 220. Gosh, I'm so sorry about all this terrible writing here. Okay, so then we're going to add 220 to both sides. So my y is going to be equal to 0.000112 x squared plus 220. So now only the next thing you have to do is just go ahead and substitute that 200 in for x. So if you remember back over here, we are 200 feet from the middle of the bridge. So we're going to substitute x in for that. Okay, so y equals 0.000112. And now we're going to plug in 200 squared for x plus 220. Okay, so we put that over here. So we're going to just go ahead and take our answer. Oh, we can't do that. So we're going to go 0.000112 times, in parentheses, 200 squared. Okay, and then plus 220. Boom. So about 224.8. So y is approximately 224, not 0.8, what was it? 224.48. And there we go. Okay. Okay, so now we're going to look at extraneous solutions, identifying extraneous solution. If you remember from quadratics, an extraneous solution is a solution we get that's not part of our solution set. Okay, so we have this square root of 3x minus 2 equals x minus 4. In order to solve and get rid of this radical, we have to square both sides as we have done before. But what ends up happening here is I end up having this, now I have x squared, instead of just a single x value, so I have 3x minus 2 equals x squared minus 8x plus 16. So if you remember how to do that pattern, it's this term squared, 4 times x doubled, right? And then, of course, it's negative 4x, so it's negative 8x, and then negative 4 squared is 16. Well, now I have a quadratic all of a sudden. Okay, so now I'm going to have to get this all equal to 0. So this becomes 0 equals x squared minus 11x plus 18. And now factors of 18 that add up to negative 11 give me x minus 9, x minus 2. So our solutions are going to be x equals 9 and 2. Okay? Well, let's see how that does for us. Okay, let's check it. So we have square root of 3 times 9 minus 2 equals 9 minus 4. Square root of 27 minus 2 equals 5. Square root of 25 equals 5. So 5 equals 5. That works out, right? So 9 is a solution. We know that. How about the other one? We have square root of 3 times 2 minus 2 equals 2 minus 4. So you have square root of 6 minus 2 equals negative 2. And that cannot be true, right? So square root of nothing can be true. So this 2 is not a solution. So that's an extraneous solution. So my only solution is going to be 9. Okay? So now, if we take a look at this graph, that was my checking one. This is my original graph of this. So this is my y equals x minus 4, this blue graph. This orange graph is the graph of the square root of 3x minus 2. It's kind of a half of a parabola. When we square both sides, this is what happens to my graph. My blue graph becomes y x minus 4 squared. So that actually becomes a parabola. Okay. This one here becomes actually a line, 3x minus 2. Well, notice now over here where it intersects only one time, and that's my solution right here, is 9, right? Over here, all of a sudden it intersects twice. So my solution is 9 and also negative 2, right? So that's how we come up with that extraneous solution. That's what it looks like graphically, okay? Okay, so you guys go ahead and try this and see how you do, okay? So here we're going to have to square this on both sides. So we have x squared plus 4x plus 4 equals x plus 2. So let's go ahead and get this all equal to 0 now because we have a quadratic. So x squared plus 3x plus 2 equals 0. This is going to factor to x plus 2. x plus 1 equals 0. So my x's are going to be equal to -2 and -1. So now let's go ahead and check that. Okay, so we have -2 first, so -2 plus 2 equals the square root of -2 plus 2. This is 0 equals the square root of 0, which is 0 equals 0. So that works out okay, right? -1, let's go -1 plus 2 equals the square root of -1 plus 2. This is +1. This is the square root of +1, which is 1 equals 1, which also checks out. So both of these guys are solutions to my radical function, okay? All right, so you guys have a 5.1 Excel. Be sure to show all your work. There's lots of work for this one, so I want to see all of it. And make sure to attach that to Google Classroom. Thank you so much for your patience this last week. I really appreciate it. I'm currently in Utah, but I'll be back next week, hopefully Thursday, and I'll talk to you later. Thank you very much. Bye-bye.